In this lesson, we're going to talk about the properties of real numbers. Now, these are not properties that you necessarily need to memorize. These are more properties that are going to be occurring constantly as we work different types of math problems this school year. So what I want you to be able to take away from this section is that when a property occurs in a math problem, I want you to be able to identify what is happening. So let's go ahead and talk about the properties. These ones on this page are going to be most likely pretty familiar to you. Let's start with the commutative property. The commutative property only works under the operations addition and multiplication. So if you see something with subtraction or addition, it is not going to be the commutative property. So I put some examples here that have numbers in them because I always find that to be a little bit helpful when you have examples that are kind of practical examples. So let's look at the first one. It says 2 plus 3 equals 3 plus 2. And then the second example, 2 times 3 equals 3 times 2. You notice that I'm using the operations addition and multiplication in these two examples. What you can see here is that on either one of the problems, the 2 plus 3 or the 2 times 3, you're going to get a number. Let's just work with the first one. 2 plus 3 equals 5, right? If we change the order of those numbers to 3 plus 2, we're still going to have that equal to 5. That is the commutative property at work. So what it's saying is that you can change the order of the numbers to get the same solution. So I'm going to write a little note here that the commutative property means change the order of the numbers. Sometimes I use this little tool to help me, but if you look at the word commutative, it starts with the letters CO, and I like to use that to help me remember to change the order. Okay, let's look at the next one, the associative property. This property works under the operations addition and multiplication. So you can see that I have two examples, one with addition and one with multiplication. And what I'm doing with the associative property is I'm changing the groupings of the numbers. So I'm going to go ahead and write that on the side here. Change the groupings. Let me explain what I mean. Let's look at the first example. Do you notice how the numbers 2, 3, and 4 remain in the exact locations on the other side of the equal sign? 2, 3, 4. I did not change any order of the numbers. I only changed the groupings of the numbers. Now, what do I mean by groupings? Well, the groupings are the numbers that are in the parentheses. So you can see that on the first side, I have a 3 plus 4. But on the other side, I have a 2 and a 3. So both of those groupings are different. So that is what is telling you it's the associative property. It works the same way with multiplication. You can see my example here below. Now, let me show you a complicated type of problem that I sometimes find that we picture the associative property as the property that uses parentheses. Well, that's true, but you can also have the commutative property use parentheses as well. And sometimes the commutative and associative property look a lot alike. So you really have to think about what property it is. Let me give you an example. So what if I had an example that looks like this? 2 plus 3 plus 4. And I'm going to set that equal to 4 plus 3 plus 2. Now, the first thing in your mind, or first place your mind probably goes is, oh, it has parentheses, it must be the associative property. But if you look carefully at this example, you can see that the order of my numbers have changed. So I have 2, 3, 4, and then I have 4, 3, 2. So this is actually the commutative property. You can also identify it by, if you look inside the parentheses, the groupings of my numbers haven't changed. It's still 3 and 4 there. So this indicates that this property is going to be the commutative property. So be really careful when distinguishing between those two properties because sometimes it can be a little tricky. Okay, let's move on to the identity property. The identity property is used under addition and multiplication, and I have my two examples over here. And let's look at the first one. It says 3 plus 0 equals 3. Well, we know that, but what it's saying is that whatever number that you begin with, you also want to end with. It's basically its identity. And so the question is, how do you get that using the operation addition? Well, the only way to get there is to add 0 to it. 0 is the only number that you can add to any number to get itself. Now, when looking at multiplication, it's a little bit different. You're not going to be multiplying by 0. Instead, you're going to take that original number, which in our case is 3, and you're trying to get that same original number. And the only way to do that using the operation of multiplication is to multiply it by 1. That's the only way. So you do have to do a little bit of deeper thinking when it comes to this property. Okay, the inverse property. The inverse, well, we know that inverse means the opposite. So we are trying to find the opposite using the operations addition and multiplication. So in my addition problem here, you can see that I have opposite numbers. I have a -3 and a 3. On the number line, they would be in opposite positions away from 0. So if I were to add those two opposites, I'm always going to end up with 0. So sometimes this is called the additive inverse property. That's sometimes what you'll hear it called. Now, when it comes to multiplication, this is a confusing one, so you just got to kind of think about it. So my example here is I give you the number 2. Now, if you just look at the number 2, doesn't every single number that we work with, can it actually be changed into a fraction? For example, like if I just write it like this, 2, can I technically put that over 1? And it makes it its rational, it puts it in its rational form. So 2 over 1 is a fraction. You can do that with any number, whether it be 2, 3, 4, 100, 1,000, it doesn't matter. So basically I'm looking at this first number as a number over 1. Then I want to multiply it by its opposite or its inverse. We know that the inverse of a fraction is called its reciprocal, where I basically turn it around to make it in its opposite positions. So I'm multiplying it by its opposite or reciprocal called 1/2. And every single time it's going to equal 1. Let me just show you real quick why it equals 1. So if I have 2 and I said that 2, we can always put it over 1. And I'm going to multiply it by its reciprocal of 1 over 2. When I multiply these fractions, remember, I multiply the numerator and denominator straight across. That's going to give me 2 times 1 is 2. And then 1 times 2 is 2. And we know that every fraction that has the same numerator and denominator, when we reduce it, it's always going to give us 1. So that's how this property works. Okay, moving on. Oh, this is my favorite property, the 0 property. Sometimes it's called the multiplicative property of 0. You might hear that crazy word, but basically what it means is that it only works for multiplication. So here's what it looks like. I kind of have an expanded example here where I have 2 times 3 times 0 times 4 equals 0. We know that anything times 0 is always going to equal 0. Sometimes it can be hidden, and in this property, instead of the multiplication signs, you might just see these parentheses looking like that, and that's fine. We just need to know the symbol for multiplication, and we know that if there's a 0 in there anywhere, it's always going to equal 0. Okay, we've talked about this next property in one of the last units, in Unit 1, one of the sections in Unit 1, the distributive property. And we'll just kind of briefly discuss it now, but we have a number that's sitting right outside of the parentheses, and the distributive property is always being multiplied. You can see here that I don't have anything under the distributive property because it's not really, it doesn't really work under one operation. It doesn't really work like that. But we do know that this number here is always going to be multiplied by whatever's in the parentheses. So I'm going to multiply the 2 by the 3x, and that's going to give me 6x. And then I'm going to multiply 2 by whatever is left inside. In my case, it's positive 1, and that's going to give me positive 2 as my answer. So that would be my final answer in my distributive property here, if I did that properly. Okay, let's move on to some properties that might not be as familiar to you. These are called equality properties. And the reason they're called equality properties is because we're dealing with equations. When we move into the inequalities unit, we'll have inequality properties. And they basically work the same way, but the only difference is they have inequalities instead of equal signs. So let's talk about this reflexive property. The reflexive property is kind of a silly property, but you're really going to see it stand out when you move into geometry. But here's what the property says. My examples here is 4 is equal to 4. Well, we know that, right? Or AB is equal to AB. Whatever's on the left is equal to whatever is on the right. So the best example I can show you that's kind of visual, and you're definitely going to get into this way deeper whenever you get into geometry. But let's say that I have these two triangles. And let's go ahead and label, I'm just going to label this line in here. I'm going to call it AB. Now, can't we state that line segment AB is equal to line segment AB? Even though we're dealing with two different triangles, let me go ahead and color them in real fast so you can see what I mean. So here are my two triangles, my yellow and my green. Now, if I were to state that line segment AB on my green triangle, it is the same line segment as AB on my yellow triangle. So the line segment is equal to one another, and that's the reflexive property at work. I know that might be a little bit confusing right now, but for right now, all we need to be able to do is just identify the property itself. Okay, how about the symmetric property? The symmetric property states, I have two examples here, that A is equal to B, but B is also equal to A. And I'm just going to try to make a little visual here for you. So let's just say I have a square. And let's say we know that a square has 90-degree angles, right? Let's call this angle A, and then B, and then C, and then D. If we know that this is a regular square with right triangles, can't we say that we know that the angle A is equal to angle B? But we can also say that angle B is equal to angle A. So this is an example where you might see the symmetric property. Now, a more numerical example that might help you is this second example. 2 plus 5 is equal to 7. Well, we know 2 plus 5 is equal to 7, but can't we also say that 7 is equal to 2 plus 5? All we did was change, we just moved it around so that we were able to see that no matter which way I write it, it's still going to be the same. It's not the same as the commutative property. It's not changing the order of the numbers. It's just basically taking the symmetry and flipping it over. Okay, the transitive property. I love this property. It's kind of a cool property. So what it says is if A is equal to B and B is equal to C, then A should be equal to C. So let me kind of give you an example here. I'm just going to write underneath the letters. Let's just say that my A is equal to 2. And let's say, let's call it 2 plus 1. And let's say that B is equal to 3. Okay, so A equals 2 plus 1 and B equals to 3. Those are equal statements, right? 2 plus 1 is equal to 3. And we already know that B is equal to 3, so I'm just going to rewrite them. But let's say that B is equal to C, which is going to be, 5 minus 2. How about that? 5 minus 2 is equal to 3, right? So if A equals B and B equals C, then can I say that A, which is 2 plus 1, is equal to C, which is 5 minus 2? Don't they both equal 3? That's how the transitive property works. Okay, the substitution property. This is probably the most, I don't know, I like to think that we're going to be using this property a whole ton this year. And we even learned a little bit about it in the last unit when we talked about evaluating expressions. So the substitution property is when you're substituting a value given a variable. So let's say that we're given the variable x and the replacement value for it is 4. I'm going to use that replacement value to substitute it into my given equation. So if I'm given 2x, you can see here, if I substitute or use that substitution property, all I'm going to do is I'm going to put that replacement value right in for x. And you can see that here. So it's really going to be, instead of 2x, it's going to be 2 times 4. And we can even simplify that down to 8. So that process of replacing the value is actually a property, and it's called the substitution property. Okay, the last equality property before we get into some other unique ones is called the closure property. And sometimes you're not going to see this very often, to be honest with you, but I like to teach it just so that you're aware of it. The closure property works like this. Okay, I'm going to use some different examples here to explain it. So let's talk about integers, okay? This is just a set of numbers. And you can see the ones below it, the natural numbers. It's a set of numbers. And even numbers, right? You're only looking at the even, you're not looking at odd numbers. And then you have irrational numbers. Irrational numbers are going to be, a set of numbers like, pi is the most common irrational number. Now, what it means to be closed is this. Let's just look at integers. Let's go ahead and add 2 integers. You can pick any 2 integers that you can think of. I'm just going to go ahead and pick -4, and I'm going to add that to 6. And we know that that's going to equal +2. Okay, so what the closure statement or closure property is saying is, if I add 2 integers, I should get another integer. So when I took those 2 integers, I did indeed get another integer, which means that integers are closed under the operation of addition. And I could even make up another example here. Let's go ahead and do 3. That's an integer, right? And let's add another integer, which is, I don't know, how about -9? That's going to give me an answer of -6. And isn't -6 an integer? So as long as you can't come up with any example that wouldn't work, that means that this group of numbers, the integers, are closed under the operation of addition. So I'm just going to put, yes, this group of numbers is closed under addition. Okay, let's look at natural numbers. So natural numbers are going to be numbers that are going to be greater, or are all going to be positive numbers, right? So you're going to have 1, 2, 3, 4, 5, and so forth. And it's not going to include 0 because 0 is a whole number. So let's go ahead and take some natural numbers and subtract them. I'm just going to go ahead and I'm just going to think of nice easy numbers. So how about 10? How about 10 minus 5? That's going to equal 5, right? Isn't 5 a natural number? Okay, so it works. But can you think of any groups of numbers that might not work? Or I'm sorry, not groups of numbers, just any numbers. How about 2 minus 4? They're both natural numbers, right? If I say 2 minus 4, isn't that going to give me -2? Do you notice how -2 is not a natural number? It's actually an integer. Therefore, natural numbers are not closed under the operation of subtraction. It has nothing to do with addition, multiplication, or division. We're only dealing with subtraction in this example. So natural numbers are not closed under the operation of subtraction. Okay, let's look at some even numbers. And it says even numbers and multiplication. So let's say, I don't know, let's pick 6 and 2. So 6 times 2 is 12. So do you notice how 6 and 2 are both even? So that means I also want to get an even number at the end, which I did. Therefore, in this example, you can see that even numbers are closed under the operation of multiplication. Now, is there anything you can think of that doesn't work? I have another example. How about just 10 times 4? 10 times 4 is 40, right? 40 is an even number, so therefore even numbers are going to be closed under multiplication. All right, let's look at the last operation here, division. And I kind of have a tricky one here, irrational numbers. We all know that irrational numbers are numbers like pi. So let's go ahead and divide pi divided by pi. Well, don't think too deep into this. Pi divided by pi is just going to equal 1. Well, 1 is not an irrational number. It's an integer, it's a whole number, it's a natural number, but it is definitely not irrational. Therefore, division does not work under irrational numbers. So hopefully that was a good explanation for you of the closure property. Okay, I've got 4 more really quick properties for you, and we're going to be talking about these properties as we go along in Unit 2 and talk about equations. Okay, but I just kind of want to review this with you with your understanding of how equations work. And I know that you've learned one-step equations in the past, so these examples should be pretty easy for you. This is called the addition property of equality. So let's say that I have this one-step equation here over on the right. To solve for that variable x, I would need to eliminate the number next to it. And the way that I would eliminate it is I would add 4 to both sides. By adding 4 to both sides, that right there is the addition property. Okay, same idea with the subtraction property. If I'm still working with the same type of problem and I'm solving for that variable, to eliminate that positive 4, I need to subtract 4. By subtracting 4 from both sides of the equal sign, I just did the subtraction property of equality. All right, multiplication. So I'm trying to solve for my variable, and to eliminate the 4 in the denominator, I need to multiply both the left and the right by 4. And by doing that, that is the multiplication property of equality. Okay, and the last one, to eliminate that 2 next to the x, I would need to divide both sides by 2. That process of dividing both sides by 2 to balance that equation is going to be your division property of equality. Okay, so hopefully that was a nice little review of the equalities for you, and hopefully you learned something new. Feel free to go back to this video and review what you need to.